And the answer to this question is yes. And so, for example, when you are differentiating something like this, you basically want to differentiate both the right and left and right hand side. So when you differentiate a function of x, then you just do the normal derivative. But when you are differentiating something like y squared, a function of y, then you treat this using the chain rule. So y squared is basically f of y of x. So when you differentiate this with respect to x, then what you get is f prime multiplied by y prime. So here, the derivative of the outside function, which is the square function, is 2x, and the derivative of y is dy dx. And so going back to your question, you treat this thing as a variable, and then you solve it. So one use of this, other than just like solving for implicit function, is when you have something that's very complicated and it's a rational function. So suppose you have a rational function, which means the top is some function and the bottom is some function, and you want to find dy dx. So sometimes using the product rule and quotient rule is very difficult. So what you do is you take the log of both sides, and this thing becomes the sum of stuff. So when you take a log of the left-hand side, it's just log y, and the right-hand side, if it's rational, then it breaks down to a sum or a difference of a lot of different stuffs. Actually, this should be minus because it's a ratio. So when you do this, on the left-hand side, you actually need the chain rule to do it. So log y, the derivative of log y is 1 over y. And remember, you need to multiply this extra thing. And here, I think I should have minus here and here as well. So minus here and here. But on the right-hand side, it's a sequence of stuff which is very easy to differentiate, so which makes differentiation very easy compared to using the chain rule or the quotient rule or the product rule. So at the end, remember, you have 1 over y here, so you need to multiply y to the other side. But you know what y is. So you know y is this whole big thing, so you just move it here and then multiply whatever is the derivative of the right-hand side. So that makes differentiation of these kind of rational function a lot easier.